Welcome to our lessons on ordinary differential equation. So far we've been taking a look at homogeneous equation, and we also look at equations that can be reduced to homogeneous. In this video we are going to take a look at equations that can be reduced to separable differential equations. The equation dy dx will however have no solution if the equation dy dx equals to this will however have no solution. The equation dy dx here will however have no solution if the determinant of the coefficient matrix AB, A1, B1 is equal to 0. And this usually happens when AS plus BY and A1 plus B1Y are scalar multiples of each other. That is, if this is a constant multiple of this, where lambda is a constant. When this thing happens, we cannot use the transformation x equals to x1 plus h and y equals to y1 plus h, because the resulting system of differential equation cannot be solved. So in such situation, we set z to be equal to ax plus by, so that the equation reduces to dy by dx equal to z plus c over lambda z plus c. And when this one happens, this equation becomes straight away separable for us to solve. So let's look at an example. Now if you pick this, you realize that the 4x plus 2y is equal to 2 times of 2x plus y. So this is a constant multiple of this. So for that matter, we let our z to be equal to 2x plus y. Therefore, the dy dx will now be equal to z minus 1 over 2z plus 5. The equation is now in terms of z, so we cannot maintain the y. So if I call this one equation 1 and I call this one equation 2, from 1, the z dx is equal to 2 plus dy dx. Don't forget, when you differentiate, this is a function, so it becomes a function of a function. So we make dy dx the subject here. So dy dx now becomes dz dx minus 2. So let me call this one equation 3. So we just substitute 3 in 2. So we are now going to have dz dx minus 2 to be equal to z minus 1 over 2z plus 5. And we simplify this dz dx to be equal to z minus 1 over 2z plus 5 plus 2. And when we solve this side, we have 5z plus 9 all over 2z plus 5. And this equation is separable. That is the dz by dx equals 5z plus 9 over 2z plus 5. So separating the variables, we are going to have 2z plus 5 divided by 5z plus 9 dz equals dx. And we only integrate both sides. But before we can integrate this side is straight away. If we integrate this side, we get x plus c by this side. So let me go and do the long division at this side. So you're going to have 5z plus 9 dividing 2z plus 5. So this 5 here goes here. You get 2 over 5. Now when you multiply it through by this, you're going to get 2z plus 18 over 5. So we subtract and we get 7 over 5. So this integral can now be written as 2 over 5 plus 7 over 5 times 1 over 5z plus 9 dz. If you integrate this, we get 2 over 5z, and we want to bring the 7 over 5 out. When you differentiate here, we get 5. But we have what we have here is 1, so we are going to bring 5 here and divide it by 5. So you can say this is times the integral of 1 over 5 times 5 over 5z plus 9 dz. So now when you differentiate, you get this. So the answer is ln of the down here. So you're going to get 2 over 5z plus 7 over 25 ln of 5z plus 9. So we have x plus c equal to that. But we know what our z is. But our z was 2x plus y. Therefore, the solution is going to be x plus c equals to 2 over 5 of 2x plus y plus 7 over 25 ln of 10x plus 5y plus 9. This is the general solution. Let's look at a second example. We have to solve the IDP. The IDS equals to this, subject to y of 0 equals to 1. So let me call this one equation 1. Again, we realize that the 3x plus the 3y is actually equals to 3 times the x plus y. So we let our z to be equals to x plus y. Please, the z is not compulsory. You can make it any letter you want. So let me call this one equation 2. So if you substitute 2 in 1, you're going to get the dy by the x to be equal to z plus 4 over 3z plus 6. And then from 2, the z dx is actually equals to 1 plus dy dx. So if you make dy dx the subject, you're going to get dz dx minus 1. So if I call this one equation 3, then if you compare, if I call this, let me call this one 3, and let me call this one 4. If you compare 3 and 4, you're going to have dz dx minus 1 equal to z plus 4 over 3z plus 6. If you decide to simplify the two of them, you are going to get z dx to be equal to 4z plus 10 all over 3z plus 6. So this equation is separable. So if you are separating the variables, you're going to have dx to be equal to 3z plus 6 over 4z plus 10 dz. Then we integrate both sides. Obviously, this is going to give us x plus c. But here, we have to do long division. And if you do the long division, you are going to get this to be the integral of 3 over 4 minus 3 over 2 times 1 over 4z plus 10. So when you do the long division, this is what you're going to get here. Now again, we know that if I differentiate this, I'll get 4, but the 4 is not here, so I'll bring the 4 there and divide by 4. So we can rewrite this one as integral of 3 over 4 minus 3 over 2 times 1 over 4 times 4 over 4z plus 10 dz. Now when I differentiate it, now I'll get a type, so we know it's ln of that. So the x plus c will now give us 3 over 4z minus 3 over 8 ln of 4z plus 10. Now, but we said our z was x plus y, so obviously you're going to have x plus c to be equal to 3 over 4 into x plus y minus 3 over 8 times ln of 4x plus 4y plus 10. So that is the general solution. But we are giving an auxiliary condition of y of 0 equal to 0. So that means you're going to get c, and this everything will go 0. So negative 3 over 8 ln of 10. And the equation now becomes x minus 3 over 8 ln 10 equal to 3 over 4 into x plus y minus 3 over 8 ln of 4x plus 4y plus 10. We want to simplify this one by multiplying through it by 10, and then if you do that, you're going to multiplying through by 8, so you're going to get 8x minus 3 ln 10 equal to 6x plus 6y, I've multiplied this here, minus 3 ln of 4x plus 4y plus 10. If you further simplify by moving the ln here to this side, bringing the 6x here, you're going to get 2x minus 6y equals to 3 times ln of 10 divided by 4x plus 4y plus 10. This is a solution to the IDP. Thank you for watching. We will meet again.